So for today, we're doing a bunch of review. We're done now. You've learned everything that you have to know. It's just that these proofs are still complicated and not easy. Would you please start by not a proof, but just to simplify? Take that. It simplifies to just a function. Instead of a fraction, it won't be a fraction anymore. It'll be a function. I hope you know that the 2 can't be any simpler than 2. But that cosecant could be replaced with something. You should go through a list in your head like, well, I guess I could put in there's something like a 1 plus cotangent is cosecant, but there's something a lot simpler than that. Cosecant, oh yeah, that's the sister function of a different function. So, Hallie, what is that sister function? So it's 1 over sine. And why is that any better? Because now if you know anything about fractions in fractions, you know that that flips and goes up. So now it's going to be sines on the top now. And the final answer, just to simplify, is 2 sine squared. Why is that any better? Because there's no fractions involved anymore. I need to know, was that something that you already knew? Raise your hand if you had that one. Okay, good. All right. Now, what if I see a tangent on the top and a secant on the bottom? How are you going to simplify that one? I'd go back to the thing that I said you'd use all the time. I said, pro tip, if you can, what? What did I say? Not if you can factor it, you should. It's not that. If you can change everything to sines and cosines, that is correct. You put your phone in your backpack and using it. That's good. Allie, can you put your phone in your backpack, please? If you ever have a situation that is absolutely critical, like my mom's in the hospital, I'm waiting for a text, tell me that kind of stuff. I can work with you. All right, that tangent part, Iris, what would that be in terms of sines and cosines? Yep. And this secant, George, what would that be in terms of sines and cosines?
1 over cosine squared.
Yep. And now, can you put it all together and simplify it all down? Now, I know I can. The question is, can you? Cancel, cancel. It's just sine. Raise your hand if you had sine squared. Okay, good. So that's simplifying. Common denominators. I just went and did the practice. I actually did the key for the test. And so I got a chance to see all of the problems. And the thing that was like hitting me is that, man, there's a lot of common denominator stuff that they have to know. So we got to make sure you know common denominators. So let's just try to keep it really simple. What if I just had 2, which doesn't have a denominator, plus 1 over cosine squared? Now, I know you could change that 1 over cosine into secant, but don't. Instead, whenever you get 2 fractions, think I should make them have a common denominator. And then I'll look at it again after they've got a common denominator. So Tully, is 1 a good common denominator?
Yeah.
So I can change the other one into 1? No, not so easy. But cosine squared could be the common denominator. So how do I deal with that, Tully? How do I get cosine squared to be the common denominator? All right. Would you agree, usually in common denominator problems, we multiply stuff by something?
Yeah.
Well, I have to multiply it by something. Come on, it's not that hard. What do I have to multiply the 1 by to make it be cosine squared? This is the denominator I want.
Cosine squared?
Yeah. Now I can do that as long as I also do it on the top. Do you agree they have a common denominator now?
Yes.
So then we can put them together. Nate, can you get me the final answer?
For the denominator,
Both.
it'd be, is it 2 cosine squared?
2 cosine squared plus 1. Yep.
And then on the bottom it's just cosine squared.
Yep. What's better about this? Only that it has a common denominator and it's all been added together into one fraction. They both have cosine squared as their denominator, so now it's just all added together. All right. Now, 1 minus 1 over tangent squared. Get them to have a common denominator. You're gonna need this stuff. Mason, what should I multiply the top and bottom by?
Tan squared?
Yep. Alex K, why did he do that? So that they would have a... Yes. And so they do. And what is it?
Tan squared.
Yep. Now what's on top?
The first one would be tan squared. That's it. It's 1 minus 1.
Now this is times 1, so I don't really need to times it by 1.
Tan squared minus 1.
Yep. Now, I'm regretting using -1 in my original problem. Everybody just forge this and make this a plus, and then make this a plus, because then I can do something cool. Tangent squared plus 1. It's on the sheet. Just grab your half sheet. If you don't have your half sheet, please dig for it, find it, because I only have a few. Otherwise, I guess you could pull it up on your iPad, but I have a few. If you can't find yours, it's okay. But you need it, so I'll hand you one. Let me pause while we get the sheets out. Okay, so we found it. It's on the sheet. And what is it, Claudia? Secant squared over tangent squared. And now I feel like I can't leave it like that. What's that power strategy that I told you would work a lot? I said it was the #1 strategy. I said, pro tip, try to... I said it within the last 5 minutes. Okay. You guys, I don't know how to get you to remember this.
Find a common.
Nope, this has already got a common denominator. Change everything to sine and cosine. There we go. So, can you tell me what secant changes into if I'm going to make everything into sine and cosine?
Yeah, secant changes to
1 over cosine.
Squared.
And how about tangent?
And tangent changes to sine squared over cosine.
Yep. And now, that can go to the top. Clean it up. See what you get for a final answer. All right, we used a common denominator. That's a big deal. Got to know how to do that. So we got it so that the denominators were the same here. This and this. Then we could add it together and there's just one of them on the bottom. Then I had to be able to find this on the sheet, and that was that. Then I had to know that strategy of changing everything into sines and cosines. So now I got to know how to do fractions where they flip upside down. If it's divided by this fraction, I can multiply by, flip it. Cosine squared over sine squared. And then the cosine cancels the cosine, and I have 1 over sine left. Should I leave it as 1 over sine? Of course not. 1 over sine is cosecant. Raise your hand if you got all the way to cosecant. Okay, good. All right, so that was a simplify problem. Do you get if it had just said equals cosecant at the beginning? It would have been a little easier because you'd know when you were done. Because, you know, this did equal cosecant. If it had been a proof, though, you can only mess with one of the two sides. You would have taken this more complicated side and done all of this stuff, and eventually it would have been cosecant. And then you would have just said, bring this all the way down, cosecant equals cosecant. Don't forget proofs, they're a big deal. All right, so common denominators one more time. No, not equals, sorry. Now, I know you could do it a different way, but would you please do this by making them have a common denominator? I just want you to get lots of practice because there's common denominator questions. So Jack, what's the denominator of the sine squared?
1.
How could I get it so that it has a cosecant on the bottom?
Multiply the top and the bottom by cosecant.
Yes. Now there's another way you could have done it, but there's what you said is right. I want to just do it that way. Multiply by cosecant over cosecant. That works. Now what's cosecant times sine? Aren't those sister functions? Do you get cosecant as 1 over sine? If this is 1 over sine and I times it by sine, do you get those are going to cancel and just make 1? If you're not getting that, let me show you. Cosecant is 1 over sine squared. And I times that by sine squared, which could be put over 1. And yeah, they're going to cancel out and make 1. That whole top is 1. So look, it's 1 over cosecant minus 1 over cosecant. They have a common denominator now. That means that you can just say it's 1 minus 1 over cosecant. What's 1 minus 1? 0. What's 0 divided by anything? This one simplifies down to 0. Isn't this exactly the same as this? Yeah, so that's another way you could just say it equals 0. They're the same. This minus the same thing, it's got to be 0. The answer is 0. You could have actually said it right there. Yes?
We could have also just, the 1 over cosecant, that equals sine, it would just be
Yes.
squared.
Yes.
Sine squared, which would equal 0.
Yep. You're absolutely right. And I was trying to force everybody to use common denominators just because I know it's on the test so much. All right. So we've done some more practice. The ones that haven't come up that much are this kind. So let's do one of these. Secant of negative x times cosine of x times cosecant of negative x times sine of x. That kind of question is for sure on there. You gotta know how to replace with things from the sheet and cancel a bunch of stuff. I bet the answer on this one comes out to something simple like 0 or 1 or -1 or -2. Or maybe it's negative sine squared. It usually simplifies down to just a number or a function, or sometimes a number plus a function. Okay. It's all about getting you to learn this stuff. So practice makes perfect. Just practicing these things. Addie, can you tell me something on the sheet that's the same as secant of -x? Yep. Regular secant of x. Now, strategically, right now, I usually say change everything to sine and cosine. But do you get it would be legal for me to change cosine into 1 over secant? Do you get why I did that? Okay. Do you get why instead of changing it to sines and cosines, I decided to change it to 1 over secant? Because look, that'll cancel that. Just like, boom, this and this change into, well, I'm going to put this over 1. That cancels out. So do you have to always change it to sine and cosine? No. It's just, it works. How about this part? Cosecant -x. George, what'd you find on the sheet?
Equals negative cosecant x.
Yep. Times sine. And if I was going to use strategery to try to get this to go faster, I'd just go 1 over cosecant right there, because sine is 1 over cosecant. And then those are going to cancel, but they leave behind something important. What's still there after I cancel everything? A negative. That cancels that, but that negative is still with that 1 that's on the top, and there's a 1 on the bottom, of course. Every time you cancel something, you leave behind a 1. I hope you know that. So then this is just a -1. Final answer. Who had a -1 before I said it? Okay, cool. All right, so we are shifting now onto this gigantic packet. If I assigned that all at once, that could be considered cruel and unusual punishment, or child abuse, depending on what your age is. Young adult abuse, anyways. So this is too much for once, but we can definitely do parts of it. And so, what we're going to do for today is you're going to work in a group again, especially on the nasty ones. And so I'm going to have you do problems 1, 2, 3, 4, and 9 through 12 today. And then we'll go do other parts tomorrow. 1, 2, 3, 4. I think it'd be totally fine to have you do those alone. Just problems 1, 2, 3, 4. Do them. Act like it's a test. We called it a practice test because the test is a lot like this. And after you've done those 1 through 4 alone, then I'm going to have you merge with your partner, and then you guys will do 9, 10, 11, 12 together. And hopefully you're starting to get good at working with somebody else. You know, that happens a lot in the real world. You get paired with people. Like, I'm teamed with 5 people that I work with all the time here. Some of them in breakup and some of them in higher algebra. That's the real world. There's not many people who just work completely alone. So do 1, 2, 3, 4 by yourself, and then in a bit I'll have you merge over with the others, and you're going to do 9 through 12 way harder.